few of the guys from third year and second year, fourth year. Okay, for that, so I need to tell you some 6 highly recommended skills for the civil engineers. Okay, when we are in a BTech, so we didn't know which one is we need to learn. Okay, so apart from the the maths, we need to study on some technical knowledge. Those things we will discuss right now before in this 6 to 4 minutes. And first of all, come to here. So the communication skills. Whenever if you come out of the college, so the main issue will be the communication skills. So communication, if suppose you go for the design company, so especially for the Andhra candidates who are in Andhra Pradesh, so we guys are very uncomfortable with this communication, like some English and Hindi. We didn't know that, and we didn't talk in a college also. So that is a main issue for us. So when we come out of the college, so if you wanted to stay around in Andhra Pradesh or Telangana, so no need to worry. But if you go out of that, so what is our main thing? So what are the communication skills we need to adapt? But I already felt whatever the things I felt, that those things I made here. So let me tell you the communication skills. First of all, if you wanted to walk around the India, so you need to perfect in a Hindi. Okay, at least one. Not only going to the India. So even though if you are join any construction company in Andhra Pradesh, there all the laborers were from Hindi background. Okay, if you are not able to speak Hindi, how can you assign some work to them? So it's too difficult. So whatever you say, that will be not communicate with him is the labor. So how can you make work out of it? So try to learn the Hindi first, and after that, if you suppose you are working with some office or anything, so English is a main thing. Okay, so we always worry about this English and Hindi. So communication is an excellent thing. That is the first highly recommended skills for the civil engineer. And apart from the communication skills, BTech certificate. Yeah, everyone having a BTech certificate. So yeah, we when we are in a 4 years of study, so we are only focusing on the BTech certificate. So apart from these, all the communication skills, 6 highly recommended skills we have, but only our focus will be the BTech certificate. Once you got the BTech certificate, so did you felt that I am enough to take any project or anything like that? No. So only we have this BTech certificate. Once you complete the BTech, so you didn't do with anything with this certificate. So, and at least try to maintain the subjects as well as, and don't put some backlogs in backend. So try to maintain the good percentage also. It's a matter. Okay, some of the MNC companies, they will ask you in the interview, did you attempt all the subjects in a one go? So they are asking you have any backlogs or not. So if you don't have, then at least they will check their all the CMM marks, cumulative marks memo. There they can point out, yeah, he didn't any this backlogs. So then they will offer you the job. I felt that. Okay, so one of the MNC company asked me all my certificate. So am I passed at early, means at one go, or otherwise having any backlogs? Yes, I send all my the year-wise certificates to them. After that, they will finalize that and they will conduct an interview. Okay, so try to maintain without any backlogs. Okay, come to the third one is a technical knowledge. Without the technical knowledge, we didn't do anything. But see, when we are in a BTech second year or third year, we already studied about a structural analysis and structural analysis 1, 2, 3 like that, and also RCC 1, 2 like that. So whatever you studied, those will be help you once you complete your BTech. Okay, but see, once you complete the BTech, if anyone asks you, so which so any about bending moment or shear force, we are blank. Why we are blank? We are only study for the marks. We didn't focus on any knowledge. Okay, so that's why we are blank, and at least we need to go back and we need to study all those things. So technical knowledge is a main important thing. Okay, whatever we studied in a BTech, so that will be only for the marks basis. So don't you even though you can't use that stuff once you complete the BTech. Okay, so and come to the fourth one, code book knowledge. Yeah, I know that. So our topic is also main. Today's topic is code books. Come to the code books. So we know 3 code books. Hardly. Yes, when I was in a BTech, I know only 3 code books. What is that? IS 456 and IS 800, SP 16. Apart from this, If anyone asks me any code book, I don't know. Simply I say, I don't know. Yeah, is that code book is available? We don't know about that. So for that, we will discuss all the code books, okay, whichever the code books will be useful, and how we can use the code books in construction and in some design. Those things we will discuss today. So software knowledge, apart from this code book knowledge, software knowledge will be mainly helpful for you. So why? Because every time in every industry, so some software should be there. If you want to, so just let me tell you simple example. Whenever you are using some, what's that? So beam design. So in RCC subject, they will give you the beam design. So nearly you will take one beam design, you will take 2 hours of time to complete that solution in exams. But come to the manual, come to after you complete the BTech and you just join as one company, the design company. There you will get 100 beams. How can you manage that? 100 beams into 2 hours. How much? 200 hours. So they will felt that I need to hire him like that. No. So we have some softwares. So softwares also do whatever you do with the manual calculation. So at the time, why can't we learn the softwares? So software will give you it within 20 minutes. So no need to spend a 20 or 200 hours of time. Softwares will give you within 20 minutes. So if you give the right inputs. So giving a right inputs is the judgment of the engineering. So software knowledge is a main thing, and I suggest you guys who are in the second year just to start learning the softwares. So we have a lot of resources to learn the softwares. So try to use those, and after that learn that. And practical experience. Everyone need experience. But as a fresher, and in our final year, up to the final year also, we didn't go any site or anywhere where is the work is happening. So we didn't go that. But at least once you complete the BTech, so at least you need to search for a job. Without knowing any technical knowledge or any practical experience, how the freshers will get a job. So this is also, we need to think about it. Okay, so my suggestion will be, at least you are in a second year or third year or fourth year, it may be, okay, whatever it may be, at least just try to visit the sites. So whatever the sites in the near in your area, so somewhere, even though it's not a big company, so at least a lot of builders will be doing the construction. At that time, at least go on there and just spend some few minutes of time there and just learn out of that. Then application in your civil engineering. Okay, I studied some bending moment and shear force in my subject, but I didn't use of this construction site. So even though we don't know what is our responsibility in the site when we are in the second year and third year, so we will only see and that. Okay, so these are the highly recommended skills for the civil engineer. Okay, so all the 6 skills will be very important. So try to learn all these things. So with you have all the, once you complete the final year, if you have all these set of skills, so you don't need to ask anyone, just give me a job like that. So jobs will come to you. Okay, I hope you understand it. Definitely these are 6, I hope I made it clear. So these 6 will help you to get a good job in after once you complete the BTech final year. Okay, so I hope before that, let me go to the IS 456. First of all, we need to discuss about some IS code books. So today's topic is IS code book, outlook on IS code book, how we can use it, and what are the important IS code books we need in a design. Okay, so design also, construction also, we can use it. And so in this session, we are going to discuss about the IS code books, and also let me tell you what are the IS codes we need to use here. Just I will give you the brief introduction about the IS codes and their uses. So yeah, go to design, and this is my blog, and I hope you already seen my blog. And come to here, design IS codes. First of all, IS 456-2000. Yeah, this is, we already know that. We already did some designs and everything in this IS 456. This is mainly for the RCC Works, and everyone say, and the Raja sir also said, this is a Bible for Bible for the Christians, and holy book like Quran for the Muslims, and some Ramayana book for us Hindus. Okay, like that we have. So this IS 456 is a main standard book for the civil engineers, all the civil engineers. Okay, if you are going for the bridge design, yeah, this is the main thing. And if you are going for the construction works, This is the main. Okay, this is a standard book. But apart from the standard book, if you wanted to go in-depth knowledge, so there you can get some separate IS code books. Okay, suppose if you wanted to, let me tell you. So when we are in a BTech, we studied all the subjects in a one BTech set, one BTech. Okay, so if you wanted to do any research, like some structural analysis research, at the time you need to go take the branch as a structural engineering once you complete the BTech, and you need to do is MTech. So like that, IS 456 is a general book for all the civil engineers. So you will get some most of the information in this code book. And if you want to in-depth, like pre-stressed, so at the time you need to go for the another code book. So if you wanted to go for the study the earthquake analysis, so you have another code book. So like that we have. And come to here IS 800-2007. So for steel structure, it is mainly for the steel structure. So steel structure also we have a hot rolled steel and cold rolled and like a PEB. So like that we have. Okay. So if you go for the steel structure, this is the main code book. And come to here IS 1893-2016 for the earthquake structures. So if you wanted to do the earthquake analysis, we need to use the IS 1893-2016. 2016 in the sense they will publish this code book in 2016. Earlier we have some 2002, I think. Yeah, it's 2002. So at the time, and after some modifications, they will publish another code book as a 2016. And come to the IS 16700 2017 for the tall building design. If you go for the some above 50 meter height and above 150 meter height, at the time you need to go for the IS 16700. And come to here and IS 875 1987 Part 1. This is a main important code books. Part 1, Part 2, Part 3, Part 4, Part 5. So Part 1 is for the dead load of the construction materials. Whatever the materials you have, some glass or AAC bricks or red bricks, like a sand and some type of materials you have, some mortar screeding, those all we will get from this IS Part 1. And the part 2 is a live load. Come to the live load. So the live load is acting on a commercial building is somewhat different, and residential building is somewhat different. Okay, so if you say residential building, only the 5 or 6 people will be staying in a room. So at the time the live load will be reduced. And if you go for the commercial building, so nearly 100 people walk around that commercial building. So at the time you need to take some higher. So due to that, we will you will get all the data in a part 2. And part 3, wind load for a different type of buildings. So wind load, wind is a main governing factor. Wind and earthquake is a main governing factor when we go for the high-rise buildings or somewhat 10-story building like that. Okay, even 6-story also I don't push you. But see, is the part 3. So if you go to the part 3, you will get in detailed details. So not only for the steel RCC structures, steel structures also they mention. Okay, so part 4 is the snow loads. So mainly Srinagar, if you go for the Srinagar or somewhere in the some places, will mainly the snowfall will happen. So at that time you need to consider the part 4 for the snow loads. So how much thickness of the load, and based on the thickness, how much load we are getting. So due to that load, we need to design our slabs like that. Okay, so and come to the Part 5 is mainly for the special loads and load combinations. Special load is in the sense of some temperature load or some blast load, and like that we have a lot of things, and there we can study this. And come to here IS 13920 2016. This is for the ductile detailing. Ductile detailing in the sense whenever if you go for the seismic area, so suppose zone 4 and zone 5 and zone 3, zone 2 we have. So if you go for the zone 5, that is mainly whenever the seismic will happen. So maybe that building may going to collapse. At the time, you will follow the ductile detailing. Suppose someone will ask me, sir, I am not in a zone 4, zone 2 I am in. So at the time, what I need to do? I need to go for the ductile detailing. If you go for the ductile detailing, project cost may increase. Unnecessarily, you are increasing the project cost. At the time, I will go for the general detailing. Which code book we will use? SP34 and IS 1987 we will use it. Okay, and come to the some another one, design aids. Yeah, this is we already know that SP 1619. So if you want to do the single reinforcement beam design and double reinforcement beam, and also we will get SP in SP 16 we will get some development length. All the formulas and all the calculation will be in this SP 16. So that's why we call it as a design aids. And the last one, so IS 10262 2019 for the concrete mix design. Whenever if you want to do the mix design, there we have some 10 steps is there. So for those 10 steps, we need to follow this IS code book. in this IS code book, all the 10 steps will be mentioned and their formulas and everything will be in this IS code. Okay, so I hope these are all the IS code book. Whenever you are familiar with these all IS code books instead of 3 code books, then at least you will get an idea how can design our building. Okay, I hope it's clear. Like we will go to the single IS code books like that, and if, right now we will discuss about the IS 456. So before that, let me give me a minute. Let me try to open some site. Okay, so just see this, and this is a general information here. Here you can see the IS 456 2000 and plain and reinforced concrete code of practices and cement and concrete, like that we have. And here, and if you go to here, and this is a reinforced concrete, and yeah. So every time, whenever if you want to going to study the IS code books, just follow this content. Okay, this content will help you to which one you need to study. And come to here, section 1. In the section 1, it's a general, no need to worry, some terminology, some symbols, whatever the symbols we use in IS code book, those symbols they mention here. And come to the section 2. Section 2 is a material, workmanship and inspection and testing. As of my knowledge, this code book will be designed with the construction activity, design activity, detailing activity. Okay, so if you first see here, so this is a materials and workmanship and inspection and testing. If you want to, which material you need to go, and how much the workmanship will be okay in our site, and inspection, if you want to do any inspections, how can you use it, and the testing, some of the testings for the materials, how can you do, and also they also mention some particular test book also. Okay, some IS code book, particular IS code book. Come to here in the material. So if you want to know about more about a cement, so go to the here and you can see, and mineral admixture, aggregate and water and admixtures, reinforcement, storage of material, how can you store these materials. So yeah, here you will get all the information. Cement, if you wanted to know any about cement, and these are the main materials we will use in RCC: cement and admixtures and mineral admixtures and aggregates, water admixtures, reinforcement. Okay, so come to here, concrete, grade of concrete, which grade you need to go, and property of the concrete, which property I need to take, and workability of the concrete, durability of the concrete. These all will be help you for the construction activity. Okay, these will be help you for the construction activity. And come to the here section 3. So here you can see the design, general design considerations. So this activity will be help you for the design activity. Okay, so when we are in a BTech, so we already study about some designs. So how we can design the dead loads, and where we will take the imposed loads and wind load, snow load and earthquake load, some of the overturning moment and sliding moment connection and lateral sway. These all things we already familiar with. Okay, so this is for the design activity. So I said this is a construction, and here is a design. And come to here, this is a special design reinforcement for the structural member and system. So if you wanted to design any special things, okay, like deciding of the position and here is a flat slabs. Okay, flat slabs and walls in the sense shear walls, and the staircases, how we can design, and what is the effective span of the staircase, and the distribution of the loading, how the load will be distributed, and like that you have, and a footing design. So if you wanted to do the footing design, you can do it. And here is a structural design limit state method. Right now we are using the limit state method for some particular building. So yeah, all we will use it. And come to some water retaining structures, so we will use the working stress method. And here is a limit state of collapse and a limit state of serviceability. These all. And if you go to here, limit state of collapse and flexural, and come to here, structural design and working stress method. And if you wanted to know about the working stress, you need to go here. And after that, see here, this is a amendments. So here is a annexes. So you will see the calculation of the deflection. If you wanted to calculate the deflection, you will use it. And slab spanning in direction, two-way slabs, and calculation of the crack width, and the calculation of the effective length of the column. These things you can see it. And if you come to here, amendment 1. So what is this amendment? See guys, whenever, so in this code book which is published in 2000, right? So if any amendment, so some of the minor changes have anything made by the engineers or someone in the committee, this IS code publishing committee, so at that time they will change those whatever the modifications we need to do. So in that only we will change all the modifications, we will release one amendment. So otherwise, if it's a very hard to print all the corrections in all the book, and we need to entire book we can't publish it. Okay, like that they will. So even if you see some only few amendments is here. Okay, so few amendments. That's why we'll use the amendments in our projects also. In my one of the projects also, we publish the amendments. So whenever the client will get a doubts, so suppose here we will give you some details, but I didn't get that point. At that time, we will publish the amendment drawings. So by showing, yeah, this is a initial, and after clear confirmation, this is the exact what we need to mention. Like that, we can do that, and we will give you the amendment. Okay. So I hope you understand it. And some of the amendments they changed. And if you have anything, see this in here also, class substituting of the following information in tables. Okay, this table will be modified in this amendment. So like that we have. And if you go to here, and this is a committee again. So here is also amendment 2. So this is amendment 2 is the September 2005 they released. And here also some of the modifications, small delete the word and. So see this. So if anywhere some grammatical mistakes or anything, at the time they will include in this. So page number 25, class 303, there they just remove the and here is the substituting for on or. So like that, these amendments is like that. And if you somewhere, if you change any formula, they will change here. Okay, so in the amendments only they will change, and the rest of them will be same. You need to follow the amendments also. So if suppose you are taking some value, so if you need to check in amendments, is there any change in that value or not? Okay, so and here this revision incorporates a number of important changes. So what are the important changes? We will see. Some of the sulfate resisting Portland cement was added, included in this. Apart from the grade 33 and 43 and 53, so sulfate resisting Portland cements also added in this. Okay, and including the super plasticizers. See this type of admixture was included in the super plasticizers. And they come to the table 2. So higher grade than see here. So grade of concrete grades higher than 40 has been included. So initially we have some lesser below M40. So they included a higher M40. Okay. So minimum grade of concrete shall be not less than M20. So minimum grade we need to use a M20. If anyone go for the M15, we don't accept it. Why? Because ISCodes say you need to use a M20 grade. So for RCC. So that and the formula for the estimation of modulus of elasticity will be revised. Yeah, see this formula also revised here. Okay, so like that you can use this and come to here and see section 4. Some clauses on walls will be modified. So and here is the section 5. The limit state method newly clause had been added. So like that the clauses on torsion and crack width, these all things will be added. So like that they say. And if you come to here and this is the symbols and these things, and again come to here. So here you can see materials and see 33 grade and 43 grade, 53 grade and rapid hardening Portland cement. And if you want to know about more about the rapid hardening Portland cement, you need to go IS 8041. So this is give you the clear confirmation about the rapid hardening cement. So IS code IS 456 never give you that much in-depth detail. So if you have any in-depth detail in another code book, that must be included here. Okay. So this is the IS 8041, and like that we have all the IS codes here and the IS 1290. Okay, some of the mineral admixtures. Okay, pozzolana and fly ash and the rice ascas, and like that we have. And if you come to here aggregates, so whatever you are in a content, so that will be you can see here also size of the aggregate, which size we will use in aggregate. See most of the work M20 aggregate is suitable wherever there is no restriction in the flow of concrete into the section, and 40 mm or larger size may be permitted. If you have a closely spaced reinforcement or small curve, use a 100 mm nominal mix size. What it means? So we need to use a generally M20 grade. So suppose let me tell you that how we can use it. Give me a minute. Suppose what it says. So if you closely spaced reinforcement, suppose that this is a see this is a beam and here we have a column. Okay, so if suppose this in this column you are getting some heavy reinforcement like this, and here also you have a beam reinforcement also. So like that you have a beam reinforcement in the middle, you don't, and this, like that we have at the time. So if you use a 20 mm aggregate, so in between this and all here also you will getting some reinforcement at the time. If you use a 20 mm aggregate, that will not passing through this one. Okay, it's a very hard to passing in between these two rods. At the time, you need to go for a 10 mm aggregate. I hope you understand this. Like that, we need to study and we need to judge in the site. So if you suppose in anywhere you are getting some heavy, heavy concrete, at the time you need to use this 10 mm aggregate. Okay. Okay. And here is the average 28 days of compression strength of that at least 150 cubes will be prepared with the water proposed to be shall not be less than 90% of the average strength of the 3 similar concretes cubes provided with the distilled water. So it says IS code says you need to do with the distilled water, but in our site there is no distilled water will be available. So whatever the water will be available, so we need to do the casting with that, and after that we need to test those cubes, some 3 set of cubes, and at least those shall not be less than the 90% of the average strength results. So if suppose you take M20, so you need to get some at least 20% kilonewton per meter square. If you are getting some, it will not be less than 90%. So like that IS codes say. And if you go to here, pH value of the water shall not be less than 6. How can you know how much is the pH of pH in our construction site? So we have some meter also, pH meter. If you see here, let me show you that. Give me a minute. Yeah, this is a pH meter. Whenever we are in some quality in our, if you have a quality control in our site, so there we can see the pH meter. So if suppose they available in our site, so this is a pH meter. Whenever if you include in some water, then it will show you the pH. So how much percentage of water having that pH range? So it's showing you 8.5. Like that also in our site also we need to check that. Okay, suppose you if you're getting any salt content in your water, so we don't supposed to do that watering or some adding in the concrete. So these things we need to care about. And civil engineer is the main responsible for these all things. So for that we need to study some IS code book, which so pH value will be shall not be less than 6. So like that. And if you are going for the seawater, how much is? So and here is a table. Table 1 is a permissible for the limits of solids, and here is a some how much solids we need to have. And if it is organic, we need to at least permissible limit will be 200 mg per liter. Okay. So even when we are in a BTech, I think the second year or third year, we will do the environmental lab. So in that environmental lab, we studied about how much is a permissible limit. Some organic content, inorganic, and sulfates and chlorides. These all things we already studied there. Once you come to the site, so you didn't remember those things. Why? Because we studied for the marks, not for the technical knowledge. So that's why we didn't remember it. But at least just study these IS code books, then at least learn some technical knowledge. And here is a modulus of elasticity for steel shall be taken as a 200 kilonewton per meter square. And if you come to here, the reinforcement, what are the reinforcement we have, and the mild steel we have, and the high strength deformed bars, HYSD bars. And right now, some of students will say, so we need to use 6 mm for stirrups. If you have a stirrup like this, we need to use a 6 mm. So 6 mm is a mild steel. Okay, so we didn't use the 6 mm for the stirrup, so we need to use a 8 mm at least. That will be HYSD. Right now, the 6 mm we will not use in a reinforcement. Where we will use somewhere, suppose if you wanted to make any almaras, at the time you will use the 6 mm. Okay, 6 mm will be not suggested by the IS code, and here is a high strength. And even though if you wanted to use the high strength, and we need to follow this IS 1786. So 1786 will give you the clear understanding about the all the HYSD deformed bars. If you wanted to go for the hard drawn steel wire fabric, so you need to go for the IS 1566. Okay, like that you can use it. And here is a character. The strength is a strength of the material below. It's not more than the 5% of the test results expected to fall. So character strength FCK. So whenever we do the cube testing, there you can get the characteristics strength. Okay, the minimum grade of concrete for a plain and reinforcement shall as per the table 5. So it will lead you to the table 5. If you go to the table 5, there you can see how much is the minimum grade of concrete you use, and property of the concrete increase of strength with age. So and here is a table 2 grades of concrete: ordinary concrete and standard concrete, high strength concrete. If it is ordinary concrete, here it will see M20, M10 and M15, M20, M25. You can't design M22. M23. Why? Because we need to follow the some code. If the code books will do the M25, so see, these all the ordinary will be, we don't need to do any mixed design calculations. Okay, whenever if you go, yeah, let me show. If you go to the ISI, these only we can do the mixed design. Okay, so these all will be we can do, and these also. So that will be dependent, and these all only these we have some particular ratio. If you go to in our ISCodes, we have some ratio. So there we can get all these, and how much 1:3, 1.5:3. If you go for the M20 and like that. Okay, so here is the designation of the concrete M. This is a most important interview question. M refers a mix, and 20 means M20. 20 refers after the 50 after 28 days of curing, how much you are getting the results, that will be 20. So 20 kilonewton per meter square. So this is the main important question. Every time if you go for the some quality control interviews, there you can ask you what is M20, how we can, what is M20. At the time you need to say as per the code book, M refers a mix, and 20 refers once after the curing, 28 days of curing, and 150 mm cube. So how much strength you are getting, that is the 20. So if it is M20, you will get a 20 kilonewton per meter square. Okay, like that only. Here is the tensile strength of the concrete and the flexural strength. This is a formula FCR is equal to 0.7 𝗵𝗂𝗃, and here is a modulus of elasticity. In the modulus of elasticity, here is a 500 into 5000 into root over 𝗵𝗃. How can you say that? If you go see in ETABS also, let me show you in ETABS. So if you open a ETABS, so here it will, once you click on define, click on material properties. Once you click on material properties, just click on add a new material. I choose India here, yeah, steel, concrete, and Indian, and here M20 I will choose. And once you click on here, so here you will get all the material mass and mechanical properties. See, modulus of elasticity E will be. So here it will give you the some formula. How you can get that formula? How you can get this value? This is a formula. 5000 into root over 𝗵𝗃. So based upon, and here is also modulus of elasticity also we have. So from there also you will see that here is also so modulus of elasticity, and how much is the Poisson's ratio, and coefficient of thermal expansion, and shear modulus. So these are all things we will get from this ISCode books. Okay, but here in the ETABS it will be the default value. But this value, where it will be, the ETABS, how ETABS will calculate it. So we already in the 𝗵𝗃𝗃 software will run with all the codings and these things. Okay, in that coding they mention if you want to go for the modulus of elasticity, you need to give it as a 5000 into root over 𝗵𝗃. Whatever the 𝗵𝗃 we mention, we choose, though that will be automatically calculated here. Okay, I hope you understand it. Every software will be like this only. Okay, so it will be already inbuilt softwares. All our code books will be inbuilt here. Okay, so like that, if you are to do total shrinkage strain is a 0.003, and a creep concrete depends upon the stress and the age, and the creep also depends upon the age and the duration of the loading, and some stresses in a concrete. And so if you want to, if you have a absence of the experimental data, you need to go for the thermal expansion, and here we have some thermal expansion of so material, what type of aggregate it is, what is the thermal coefficient expansion for concrete. So like that, and here is a workability, and the workability in the sense workability. So if it is a bleeding concrete and shallow sections, and the pavement is in pavers, and we need to go for the very low workability. And here is a mass and concrete, heavy, lightweight, reinforced sections in the slabs and beams, walls, and floors. So we need to go for the low. And if you go for the pumped concrete, so what is a pumped? You need to know that. And it's a pumped concrete, you need to go for the high workability. So it will be, slump will be at least 100 into 150. How we can see? So what is a pump? I don't know. I hope some of you guys are know this pumped. Some of might be not know. So let me show you what is a pumped concrete. How it look like. Yeah, see this. And also another thing I need to show you. Yeah, this is what pumped concrete. So whatever the see in the below of the see, this is in some 5-story height. So at the time you need to bring that concrete, whatever the concrete in a mix that means vehicle. So you need to pump in this top floor. At the time you will lay the pumps. So this is a pumped concrete. If you maintain some workability will be nearly some like that. How much you mention? So 20 or 75 or 50, 100. So how can that concrete flow? into the top floor. So that's why whenever you using this pump type, so at least you need to go for the, as a quality engineer, you need to check out of it. So whenever the mix design will came to the site, you need to take the sump clone and you need to take some values from that, and after the, so you need to do the some initial testing, and if the suppose the concrete will be somewhat flowing, at the time you don't need to do any water adding, and then you can directly send it to the top pumping. Okay, otherwise if suppose the workability is be not somewhat higher, I mean thick, if the concrete will be thick, you need to, as a initially we need to add some water in that mixer also, just rotate that mixture. After that you need to once again just go to the top in that mixer vehicle. So you need to check if everything is clear, you need to send it to the site. So otherwise it will be the main issue. But even if you suppose, if you see guys, one thing happen in the site, if you didn't add any water in the initial stage when you are in a downside, so in the top they will, site engineers who are working there, so they will add the water. Okay, that is a main issue to every time the clashes will be happen with the quality engineer and site engineer. Site engineer always thinking about complete the work, but quality engineer make sure that it will be quality. Okay, so that's why every time it's so whenever if you go for the slab reinforcement, there you can see all the debris in the beam column junctions there. Okay, quality engineer needs to be restricted that. So site engineer, if he said yes, I already cleaned, but again it's dust will came. So these type of things will be happening in a site actually. So those things once you see those, you can understand it. And here is a, in very low slump will be somewhat value of the compaction factor will be 0.275, 75 and 8%. And here is a factors influence of the durability include. Okay, so durability mainly depend upon the environment. If suppose if any raining will be so tomorrow I need to do the concrete work, so today it's raining. Okay, so at that time your workability and durability may change. So all the aggregates and this will be in the wetted condition. At that time you need to decrease the whatever the water content you are supposed to follow, you need to decrease the mix water content. So at the time you will get a proper durability. So those also main issue. And the cement concrete and water cement ratio also, it will be leads to the influencing the durability. Okay, like that we have. And if you go to here and reinforcement for a durability and promoting the good drainage of water and adequate curing, it will be, yeah, adequate curing is the main thing, and the proper compaction. And also from here, and the life of the structure can be lengthened by providing the extra cover to the steel. Yeah, cover is the main important thing. If you provide an extra cover, so the life of the structure will be increased due to exposure condition and fire resistance. Those things will happen. And here is the environmental exposure. And it's come to environmental exposure. So this is a mild and moderate and severe and very severe extreme. What is the extreme? Surface of the members in a tidal zone and members is directly contact with the liquid or solid aggressive chemicals. So at the time you need to choose extreme. If you choose extreme, all the grades will be changed, and all the some water cement ratio will be changed, and the cover will be changed. Okay, based upon these conditions. So and here the required different sulfates in the pH concentration near natural groundwater having a pH is 0 to 9, and require reinforcement of the cover. So nominal cover is the reinforcement shall be as per the 26.4, and concrete mix proportions. These mix proportions I need to cover in another webinar. So I need to do the one mix design webinar. So in that we will see in depth how we can calculate the step by step. Those things we will cover. And here is a cement minimum cement content. How much is the minimum cement content you need to use? And 250, 280, 330, and this we have. And here also, if you go to the mix content, and here is a chlorates in concrete, and how much so how much is allowable chlorates in concrete and sulfate in table. And some every time if you want to follow that, the tables is a main important thing. So try to remember these tables. And so here you can see the plain cement and reinforcement cement, and this is a mild and extreme. I already told you, if it is an extreme condition, the grade will be changed, and the cement content will be changed, and water cement ratio will be changed. The minimum grade you need to go for a M40 if it is an extreme condition. If you are working in any seashore, so at the time you need to go for a M40 as per these code books. Okay, so this important note here, you can see the note. So every time you need to very cautious about this note. So here you will get a lot of information. Minimum grade of plain concrete under a mild exposure condition is not specified. So like that, it particularly will tell you some important information. And the chloride contents, how much is the limit chloride contents we need to use. And here is a 0.4. It's a concrete containing the metal and stream and cured at elevated temperatures. So and here is low alkali. I hope these all things not important for you. But come to here design mixes, and if you want to go for the design mix, here is a concrete mix proportion. The designing the mix is a design mix concrete, and the adapting nominal concrete mix, it's called as a nominal mix. A nominal mix in the sense M20, M10 and M15 and M20. These are the nominal mix, and they come to the design mix and 25 and some 30 and 35 and 45 like that. We call it as design mixes. Okay, and here these all the information formulas, type of mix and grade of, and even though if you go to the IS 102, I think 102.290, there also you will get this all the information. Same information you will get there also. So based upon these are the step-by-step procedure to achieve the concrete mix design, type of mix and grade of, and these all things. And so if you go to the in-depth detail and design mix, and we need to go for the standard deviation. Standard deviation is a 1.6 into x like that we have, and that standard deviation it will be depend upon. Here also you will get some brief introduction about the concrete mix designs. But if you go to the IS 10920, so there you will get a maximum input. Okay, so nominal mix, it is a nominal mix, how much is the quality of water per 50 kgs of cement we need to use. Okay, so here is a quality control job, and complete here batching, admixture, quantity of admixture, and these things. And yeah, let me show you some of the important things. And the stripping time is a form work. Okay, so every time if you are doing a you just did some concrete work, after that you need to remove the form work. How much time you need to remove the concrete work? If suppose it's a vertical frame or columns or beams or walls, we need to maintain a 16 to 24 hours of time. Okay, if suppose this is your column and you casted a column with 1 meters, 1 meter. Okay, for the form work you did, and after that you poured some concrete. So and so when I need to remove this shuttering, and I need to place shuttering here. Okay, so the rest of the 1 meter I need to place the shuttering. So at least I need to provide a 16 to 24 hours. So nearly we will follow the 24 hours. Once after the 24 hours, we will remove shuttering here, and we will make a shuttering in this above, and we will pour the concrete. So like that. And if it is a slabs or anything, so fit from form work to the slabs, how much days? 2 days, 3 days we need at least. And if you go to the here, so fit of form work to the beams is 7 days. And if you come to here, see here you can see props to be refixed immediately after the removal of the form work. See guys, so if you have a heavy beams, so if you have heavy beams, at the time if you remove all the supporting condition, it may going to somewhat deflect. Okay, like that it will so due to wet condition, it will be going to try to bend like this. So at the time you need to at least need to fix the props. So yeah, if you go to the props for the slabs, here is a spanning into 4.5 meters. You need to go for the 7 days, and if it is a spanning over the 4.5 meters, it is at least 4 days. If suppose anyone will be removing in 3 days, at least you try to oppose him. So why? Because they don't know how much is effect will be happen. But as a civil engineer, we don't know that. So that's why at least we suggest to just at least go for 7 to or 14 days to remove the slab shuttering. Okay, so every time in the construction, everything will be going to fast. At the time they will remove the next day, and they will cast another level. So that is the main issue for the civil engineers, and the structure is also not that much good. And here is a props left under if you want to study more, and you can see here, and the tolerance for the placing of the reinforcement, and how much is the tolerance for the placing of the reinforcement, plus or minus 10 mm we need to follow. If it is a depth will be 200 mm. It is the effective depth, and the tolerance for the cover. If you go for the cover, required nominal cover is a cover by 10 mm plus, not 0. So plus, it's not a plus or minus 10. It will be plus 10 minus 0. It means if the suppose the engineer will give you 10 mm 20 mm cover you need to provide, at least you can provide a 30 mm. By plus 10 you can provide a 30 mm. You can't less than 15 you can't provide. So why? Because we already studied, but how much cover you are processing, the length of the life of the structure will be increased. So try to increase the cover, but don't decrease the cover. Okay. So, and if you go to here, and the tolerance and the mix maximum permissible free fall of the concrete may be taken as 1.5 meter every time if you are concreting. So at least try to maximize 1.5 only. So far free fall, and even though if you go for the 2 meter side, even though your vibrators are not sufficient to go for the in-depth vibrator, whatever the vibrator which the machine will carry, so that vibration is also not sufficient. So it will be mainly long, and yeah, we will get a long vibrators when we go for that type of situation. But most of the small constructions, at least we need to go for the 1.5. And over vibration, under vibration, the concretes are harmful, should be avoided. Vibration of very wet mixture should be also avoided. Okay, so over vibration we didn't do, and the lesser vibration also we didn't do. So if you just done the over vibration, all the it will be may segregate. Okay, so like that. And construction joint, how can you place the construction joint? Where we will place the construction joint? If it is some 20, some 40, or so it is 120 meters of building, 120 meters of building, where I need to provide the extension joints. Okay, exactly where I need to provide the expansion joints and construction joints. So if you see, the construction joints shall be complying with the IS 𝗂𝗏𝗖𝗍𝗃 code book. If you go for the IS this code book, you will get a exact answer for this. And here, if you see, the period of cooling shall be not less than 10 days for the concrete exposure to dry and hot weather conditions, where the mineral admixtures as blended cement or used. It recommended that above minimum period may be extended by 14 days. So you need to go for at least 10 days. But if you have any admixtures you use, and you need to go for the 14 days of curing. But I suggest you to just do the 28 days of curing. So curing must be done at 28 days. What is the main thing here is, so as of my knowledge, see this, if suppose you are casting a one cube here, okay, exactly, this is a cube. How much this one cube? 150 into 150 into 150, right? 150, 150, 150. So after casting this cube, what we will do? So we will take this cube and we will place in a water curing area. Okay, in this water we will get a 1 pen. After that, 28 days of time. After 28 days, we will remove this cube and we will test it, and we will get a 20 kilonewton per meter square. Is this position, right? So, but come to the construction, what we will do? Morning one time we will do the concrete, evening one time we will do the concrete. But so for we need to achieve the 20 kilonewtons in the site also. Kilonewton per meter we need to achieve. But come to the here in the design, what how we can do the test? 28 days of cure we did completely. But come to the site, morning 1 hour, it's not a 1 hour, just wetting that column and beam. So evening also 1 hour. Is this 2 hours of 2 hours duration curing? It will give you the 20 kilonewtons of load, 20 kilonewtons of strength. Did you felt 2 hours of curing will give you the same results, the 20 kilonewton of meter square? I supposed to, it will not give you, it's nearly give you some, as per this, 10 kilonewtons per meter square, even though it will be less than 10. How can you suggest to them? So go for that morning and evening curing. So try to tell them at least do the 24 hours of curing. Yes, it may be, cost of the curing may be increased. So cost of the structure means life of the structure is important rather than the cost, right? So try to provide, you need to cure 28 days of complete curing. Morning and evening, it will never give you the this one. And if you come to the afternoon, if the heat will be somewhat higher, so what will happen? Heat of hydration will happen. So afternoon, no one can cure that columns and beams. At the time, so most of the strength will be loss at the time only. So whatever the heat of hydration inside of this column, so that will come out of it. So it will never get that much strength. So try to maintain the 28 days of curing. So see, I hope you understand what I said. So in testing, we did a 28 days of curing. But in an actual site, we are doing a morning and evening. So it will never give you the results. So that much strength. So that's why some of the engineers will design our structure for a 20 kilonewton per meter square, M20, and they will give it to the site M30. They will give for the 20 kilonewtons M20. They will get some beams and reinforcement, all those. And if you give it to the M30, they know that it's done, curing is not properly done. So maybe our strength will be may loss. If you give it as M30 design, so at the time at least it will reach to the M20, right? So that's why some of the consultancies will do like this. Okay. So at the time it will be the structural engineer may going to save. Okay, and yeah, and come to here, impossible member, and here high strength is required. Come to here, this is a concrete member special condition. Work in extreme weather condition, we need to follow some IS code books, IS 8761. And underwater concreting, what we'll do? So is for aggregate 40 mm aggregate particular size and cement concrete shall be at least 350 kg per meter cube. If it is a normal, you will need to take some kilonewton per kg per meter cube. But if it is a water concreting structure, you need to go for a 350 kg per meter cube. So concrete you need to follow. If you don't follow this one, so you will never get any approvals. Okay, so they will check as per code books they followed or not. They will check that. Okay, 𝗵𝗵𝗖𝗢𝗗𝗏 is a 𝗵𝗵𝗫 pipe shall be not less than 200 diameter in less in die. Okay, whatever the I see in this, this is the 𝗵𝗵𝗫 pipe. This will be at least 200 mm. Okay, the concrete placed through the vertical pipes and lower end of the which is always inches sufficiently deep into the concrete which has been placed previously and as meant. Okay, so like that we can see. And here is also some sampling and strength of the designed concrete mix. Okay, sample of the fresh concrete, and these shall be these all the some of the, and due to time being I will make and I need to explain all these code books. If I yeah, we have a lot of information in IS 456, but I'm sorry to skip this IS 456 a little bit, but anyway I need to cover the rest of also. So try to, yeah, let's see this. And if you want to do the specifications, you can. And here is a flexural strength of the concrete, and this, and here is a concrete strength is less than 0.3 kilonewtons, and some of the percentage. And again, it's a load test for the flexural member. If you wanted to do the flexural member load test, and we have some procedures also. And maximum deflection for the shown in during 24 hours of load less than 40 LD square by D. Okay, it will be maximum. Non-destructive test. Non-destructive test is a very useful test whenever if you want to not doing any test. It's one type of mission actually. Mission, not a mission. It will like one hammer. Okay, so by hammer you will get how much strength is acting. So if you want to existing, you already so in some of my MES projects. So in MES project, this test will be used actually. So whenever if you just hit that column member or anything, then it will show you how much strength it has. So like that you will get this, and non-destructive test. And here is a method of design. So come to the design. We already studied all about this design, guys. I hope when we are in a BTech, we already studied if it is a slab, how much you will calculate it. These are all the designs, you will know that. So I just skipped some of the part. And if you go for the imposed load, wind load and the snow load, these all things, earthquake load and earthquake force, it will show you the some IS code book. Here also you will get all the code books here. So IS 456 suggests you, and the unit weight of the plain and reinforced concrete and 24 and 25 kilometers such structure shall be requirement of deflection. So if you wanted to check the deflection, here is a clause 23.2 and cracking 35.3.2 you need to, and a limit state of serviceability. And this is other forces affecting the foundation. So see some of the effects. See, guys, what is this? And some of the earthquake movements, the foundation movements also will affect the structure. Elastic axial shortening and soil and fluid pressures, vibration, fatigue, impact and erection loads. If you wanted to go for the impact loads, where we will find that part 5. Part 5, it is a special loads and load combinations. At the time, if you wanted to study more about the impact loads, you need to go for the part 5. So lateral sway, how much is a lateral sway? Lateral sway in the sense, see in code book also, if it is a building, okay, it's some G+10 story building. So earthquake will be acting on here. Okay, earthquake and wind load also will acting on here. At the time, how much lateral sway? This one. So how much I need to permissible? This how much is a permissible? Here we have a value h by 500 wind load. If you go for the wind load, at least you need to h by 500. H in the sense height of the building. So how much is height? It's a 10-story building. How much? Nearly 3-story. Each story is a 30 meters of height. 300 by 500. Then you will get a, so this permissible. If you suppose you are getting higher than this permissible strength, you need to change the column orientation or column size, or you need to include the shear walls, like that you can. Okay. So this is the main thing, and minimum reinforcement in a concrete. These all things we will do. And here is a overturning. So overturning 1.5 times the maximum, and like that. And here also, so effective span. We all know that span plus effective depth of the slab and these things. And again, if you go to here, table 2 is the bending moment coefficient. If it is a continuous beams, you need to follow this one. Shear coefficient. If you are going for the continuous beam with to calculate the shear force, these are the coefficients. Okay, so by using these coefficients, you will get a bending moment and these shear forces. Okay, and here is the beams effective depth and T beam, L beam, general things actually. So here you can see the final deflection. So how much is the deflection we need to take, and so deflection limit and span by 250, or otherwise span by 350. When we will go for the span by 350 or 20 mm, at least we did deflection. Okay, whenever if you get a deflection, so this will be these values. Okay, 20 bed, like that we need to, and should be normally. And here is a control of the deflection. If you want to do the control of the deflection, cantilever, simply supported, continuous. Based upon this, we will design a depth or whatever it may be. Okay, suppose span by depth, right? So if suppose, let me explain you, this is a continuous span. So you just length by depth. If you want to suppose calculate the slab depth, so 26. My slab will be 3 meters. At the time 3 meters by 26, you will get a depth. It's the initial estimation of the depth. Once you done the analysis, then you will get the deflection ranges. If suppose the deflection is more or less, then you will increase the depth. Otherwise, you can decrease the depth. That will be purely depend upon the engineer calculations. And here also I strength of the deformed bars, HUHD shown values. This is also, see here, provision applied to the slabs also. Okay, solid slabs. If you go for the solid slab, and the slabs carrying the concentrated load, concentrates also we need to consider on the slabs. Okay, and this planning slabs planning in a 2 direction designed by, see, this is a one important thing, yield line theory. So every time if it is a yield line theory, suppose here we have a beam, and here we have a beam, and here we have a beam, and this is a slab, right? So this is a 2-way slab. Yield line theory will always follows like this, and whatever the beam you have, so by this all the trapezoidal load will be acting on this beam, and this triangular load will be acting on this beam. Okay, this triangular load will be acting on this. Okay, like that. Even though if you have another slab here, so again it will be divided like this, trapezoidal and triangle. So trapezoidal, all the load will be transferred to this beam. This beam may getting higher bending moments as compared to this beam. Okay, so why? Because only one trapezoidal load will be acting on here. If you take these two, so 2 trapezoidal loads will be acting on here. Okay, so like that. And this is a yield line theory. Yield line theory is also main important, and we will use the FEM concept, the finite element method. So finite element now. So if you go for the MTech students will know the finite element concept. And here is a development length. The development length, we have a formula, LD is equal to gamma into sigma is 4 into tau BD. Tau BD, sigma S is a 0.87 Fy. Fy is since whatever the bar you are providing, that is. And if you go to again some tau BD, you will get a formula like this here. Okay. So if you wanted to do the tau BD, if it is a HY, this is for the plain bars. If you go for the HYHD deformed bars, we need to increase the 20%, 60%. At the time, you need to multiply it to 1.6, then you will get a 1.92. Okay, then you need to inbuild this 1.92 in this tau BD. So in this tau BD. Okay, so then we will get a LD, development length. Development length compression will be different, and this will be different. And let's go to the next one.